So a fraction is nothing but really two numbers, one on top of the other. That's it. Okay. Any fraction, no matter how weird it is, it boils down to that just simple fact. Okay. So examples of fractions are 6 over 8, 8 over 3, 543 over 42. Obviously, I just chose random numbers. What I want you to know from here is that it doesn't matter, okay? It doesn't matter which number is bigger and which number is smaller. Now, I know that so many math teachers, whenever they talk about just the word fraction, just the word fraction, they always refer to things where there is what? Which number is bigger here? The bottom, the top, or the bottom? The bottom. So math teachers usually, when they talk about just the word fraction, they refer to something like this: 6/8, not 8/3. I'll tell you what they call it then. Not this one, because this guy is bigger than this one. They talk about this one because 222 is smaller or lesser than 444. They're not talking about this one. They are talking about this one because 85 is less than 128. Okay. The name they have for things like this, so let me highlight so it appears on the video. The name they have for things like this fraction or this fraction or this fraction, where the top where the top is bigger than the bottom. Does anyone know what they call it? You might have heard the name before. Hmm. Yeah. Oh, so okay. By the way, the denominator is always the bottom part, and numerator is the top part. I'm talking about what do math teachers call a fraction, where let's call your terminology, where the numerator is bigger. Improper. Improper, like not appropriate fraction. Okay. Why? Because you can always make it what we call what? A mixed fraction. Mixed fraction. So basically, which is our lesson not tomorrow, on Friday. So basically what they say is this, sorry, this is a fraction. This one is a what? Improper fraction. Why? Because you can turn this guy into a what? Into a mixed fraction. Like when they say mixed fraction, yeah. Like when they say 3/2 could be written as one and a what? One, yeah. If you divide $3 by two people, each person equally gets $1.50. So one and a half. Okay. This is our lesson on Friday. We will learn how to start with improper and make it mixed, and how to start with mixed and sometimes make it what? Improper. That's Friday's lesson. So you don't have to worry about it today. But today we are calling everything fraction. Okay. I've been, I mean, like easygoing enough that as long as it's two numbers on top of each other, I just call it fraction. I couldn't care less which one's big, which one's small. Sorry, where's the bigger one? Where's the smaller one? Okay, so the top number, the numerator can be anything. Okay, it can be. Oops, sorry. So it can be. Let me actually see what kind of answers I got, so I don't make a mistake. There we go. So everyone, so go ahead. So the top one could be anything. It could be an odd number. What are odd numbers? Odd numbers are basically numbers that end with 1, 3, 5, 7, 9, like 13 or 27 or 89, and so on. Even numbers are the numbers that end with what? With even numbers. Actually, even before 2, 0, right? 0, 2, 4, 6, 8. Okay. The top part could be large, like this. It could be small, like this. Same thing with the denominator. I could give you an odd number down here, like 33 or 3. I could give you an even number down here, like 128 or 444 or 432. I could give you a large number, like 444 or 432 or kind of 128. I'll give you a small number, like 3 and 8 and so on. So the options are honestly completely open. Okay? Today's lesson is going to be mainly concerned about taking a fraction with what? With big numbers. You want to go? You want to go and take it? Okay. Okay. Taking a fraction with big numbers. How big? I mean, could be this big. Could be this big. Depends. And have them what? What's this word? What does the reduce mean? Up or down? Whenever you reduce something, you're basically taking those numbers and what? And making it reduced, or makes the numbers smaller. Why would you do that? Because it's always easier to work with smaller numbers and you're lesser prone to make mistakes than if you're working with big numbers. Okay? That's mainly the whole point of today. Okay? So this is the first thing. All right. So let's look at this here. So this is so what we said here. It's odd, even, big, small, or large. Yep. Same. How many of you have seen this sign? Yep. What does it mean? It means basically two things are the same. So this one's the same here instead of copying the exact same thing twice. Same thing, same thing, same thing. Okay. So here was reduced. By the way, some teachers call it what? Call it what? Yeah. I like to. I mean, doesn't really matter if you're simplifying a fraction, you're also reducing or shrinking the number. Okay. Which means the numbers here are smaller. Okay. So here are examples of fractions that could be simplified very quickly. Mostly because the numbers are what? Are they big or small? Small. Okay. Okay. Question, everyone. 4 divided by 8. 4. If you have $4, everyone, if you have $4 and you want to divide them by or divide it by 8 people, how much does each person get? If you're obviously if you're able to what, to break it into cents, right? Say again. 50 cents. How much of a dollar is 50 cents? Half a dollar. Well, guess what? That means that's what we're gonna build up today towards 4/8 could become 1/2. Sorry. Or you could even bring it down to what? 2/4, which finally could be brought down to what? Can you simplify 1/2 anymore? No. I'll give you always a fact. If you make it such that one of the numbers is what? 1, you're done. Because 1 cannot get any smaller. So once one of the numbers hits 1, either the top or the bottom one, that's it. Simplifying is done. You're done the question. Okay? How about 10/4? Say again? Interesting. Because so Muhammad said, oh, $10 divided by 4 people, if I could give them cents and bills or toonies, or loonies, I guess, or toonies, each person should get what? $2.50 or 2.5. Well, here's the thing. 2.5 is another way of saying what? 5/2. Here's the thing about 5/2. You cannot bring 5/2 any smaller. That's why this got smaller. This one, you had to stop here, which itself cannot become anything else that is smaller. Okay? All right. This one, 12/4. You can take it easy and go what? 3, but before that, you can go at 6/2. By the way, just so you know, whenever you simplify fractions, it depends always on how well do you know numbers. Sometimes you can see what big divisions happen right in front of your eye, and you can jump a couple of steps to the final answer. And sometimes you're like, no, I'm gonna take it easy. I'm gonna go slowly by the numbers. So 6/2, which goes down to what? 3/3 over what? Did we create a 1? Yes, we did, which means just like here, once you hit a 1 either here or here, either above or below, you always say that's it. I am done simplifying. No way this could get any simpler. Okay? All right. Those were easy. Why? Numbers were small, and the numbers we know how they can go down. Well, what if I give you just a random? What if I give you this one? Sorry, just leave me a second. What if I give you, for example, I don't know, this one, and just ask you for the possibility of, do you think this is gonna go down? And if it does, how much? You don't know. Well, today we discussed it. Okay, so how can you make sure? How can you make sure that those fractions that you simplified are the same as the ones that you started with? Can someone tell me what's the title on top of the page? Like the header. Simplifying fractions and what? and checking with decimals. If you're ever in doubt that your fraction at the beginning is the same as the fraction at the end, put both of them as a decimal, like just plug them in into your machine or calculator or cell phone. And if they produce the exact same decimal, sorry, if they produce the exact same decimal, you got it right. If they produce a decimal with even a small difference, you did not produce the same thing from the original. Okay? So let's actually do this. So 4 over 8. Well, no surprise there. All you have to do is just do this. 4 divided by 8. What's the decimal? 0.5, okay? Don't say half. I mean, you could say half. But I guess when you say half, you could also say, oh, I'm talking about the 1 over 2. We will get to that. So it's 0.5. Okay, what did we say the next step was? The next step was simplified into 2 over 4. Well, guess what? 2 divided by 4 is also a half. So far, we are producing the same thing. See, this is what you have to understand about fractions. Two fractions could look different. Look, yet they produce the same what? The same what? The same exact. As long as they produce the same decimal, it doesn't matter that they look different. They are really the same thing. Good. Okay. No need for this highlight. And finally, I guess our last step was 1 over 2, which I don't think we need to do this again. And we know it's a 0.5. Done. That's it. So the fact that you always kept producing the same decimal lets you know that all of those fractions are the same. All right, let's do the next one. 10 divided by 4 as a decimal. 10 divided by 4 is as a decimal. 2.5, which is what Muhammad said. Each person gets $2.50. Yep, $2.50. And we simplified it to 5 over 2. Well, let's check. No surprises. 2.5 as well. So we are producing the same decimal, which means we are still keeping the same fraction, even though it looks different. See, in math, things could look different, but they are still the same meaning. That's the whole idea. Finally, 12 divided by 4, actually 12 divided by 4 is a perfect division. It's 3 whole dollars. Awesome. So it's 3. 6 over 2, no surprise. It's also 3. 3 over 1, come on, any number divided or multiplied by 1 gives back the exact same original number again. So it's 3. Yep. I know that 3 is not a decimal, but at least it's the same number repeated 3 times. That's the whole idea. Okay. The question is, how do you actually create those fractions, the 6 over 2, the 3 over 1 from the 12 over 4? How do you create 5 over 2 from 10 over 4? How do you create 1 over 2 and 2 over 4 from 4 over 8? So the question now is, how do we actually create or get those simplified fractions? In other words, how do we actually take a fraction, like the original one, and reduce its numbers to become smaller, yet giving the exact same decimal? Because if it doesn't, you've screwed up or you've changed the number. Okay, you have to find, you have to find what I like to call, you have to find what we like to call, a second, dividers. Or some people call them what? Divisors. Okay, so some people call them divisors, and some people call them dividers. I usually call them dividers because they come straight from the verb divider from divide. Okay, but it is a common word to see in math courses and with math teachers saying divisor. Okay, what's a divider? A divider of a number is a number that could divide that. So what I mean, I know that was like a circular, like a logic thing to say. Okay, so the answer is we have to find the dividers or divisors of those numbers and divide the numbers by 1 to make it smaller. Okay? So what does this mean? Okay. So I'm going to say, oops, sorry. That dividers or divisors. Okay? To make them smaller. Okay. All right, everyone. Let's take an example. Let's take an example. And let's say our example is 24 over 16. Pencils down. Let me run you through the process. I want you to live through it. Let's look at the number 24. What numbers divide 24? In other words, what number could you write 24 divide by it and it still give you a what? A whole number. What number do all numbers divide? 1. All numbers divide 1, right? By the way, if you ever want to check that a number divides another number and gives you a whole, just do it right here. Just actually plug it in. You know what? I'm not gonna waste your time with the calculator on the screen. There we go. Sure. Yep. There you go. Clear. Clear. 24 divided by 1 gives you obviously what? 24. As long as the result is not a decimal, that checks out. So that means what? 1 is one choice. Go ahead, write 1. 1. Do you think 24 divides 2? Do you think 24? No, but okay, step by step. Always start small. Do you think 24 divides 2? You just have to ask yourself one question. Is 24 an even number or an odd number? Even, because it ends with a 4. All even numbers divide 2, or they sometimes call it are divisible by 2. Like you can give it to 2 people and you would get absolutely nothing back in return. Okay, so 24 is divisible by 2. Do you think 3 works? I'll give you today a very super neat trick. Seriously, uh, for some weird reason, it does. It does. But I'll give you today a trick where you can at least be sure. You might not know the result, but you can tell if it's a yes or a no. For some reason, some students don't know it. Question, everyone, pencil down. Focus with me here. I'm gonna write a number on the board. I'm gonna make it a big number, like consisting of a lot of digits. Yeah, 3, 7, 1, 6, 5, 8, 2. Trust me, random selection through my mind. I want to know if this big number, which trust me, I don't have the mental capacity to actually do it in my head, but I just want to know if this number divides 3 or not. Before I say the trick, does anyone know the trick? The trick is simply add those digits. All right, let's do it. No, let's do it together. Come on. What's 3 plus 7? 10. Keep going. 10 plus 1. 11. 11 plus 6. 17. 17 plus 5. 22. 22 plus 8. 30. 30 plus 2. Now you just have to ask yourself one question. Does 32 divide 3? It doesn't. Go ahead. Go ahead. Try it. Try it. Go ahead, everyone. Try 32 divided by 3. Try 32. 32 divided by 3. Oops. What did we get? Not just any decimal, an infinite decimal. So it's the worst kind of decimal. So does this number divide 3? Go ahead. I want you to try it now. What did you get? No. You tried 32 divided by 3. What if you didn't do that trick and you just brute force did this thing and then you did divide 3? I guarantee you're going to get a decimal. It's not going to work. There's no way you're going to get a whole number. Yep, you got an infinite decimal again. Okay, everyone, check this out. I'm going to tweak this number to make it work. Question. What was the addition we got? If we got 33, things would work, right? Because 33 does divide what? How different is 33 from 32? Just what? Just one number. All I have to do is increase one of those numbers by, sorry, one of those digits by. No, let's keep it. It doesn't matter. Let's make this what? A 4. Let's re-add now. 4 plus 7 plus 1 plus 6 plus 5 plus 8. Try it now. Go ahead. Divide. Come on. No, not the addition. Let's prove the original number works for our purposes now. 4716 582 divided by 3. What'd you get? You got what, sir? 1. Did you get a decimal or nothing? We got what? We got a whole number, and that worked. You see how neat this trick is? I guarantee you can go to some grade 12 students and they wouldn't know it. Now you know something they don't. Yes. All good? Okay. Yeah. So that means what? Okay, so let's apply it, everyone. Why did I teach you that trick? Let's apply that trick to 24. What's 2 plus 4? What's 2 plus 4? 6. Does 6 divide 3? 6 does divide 3. So that means what? 24 also what? If the addition of the digits divides 3, go back to the original number, it checks out. It does divide 3. Good? Without doing anything in your head. All right? So 3 works. 3 works. Do you think 4 works? Does 24 divide 4? Again, you can try it. Everyone, what's 24 divided by 4? It gives you 6. So it doesn't give you a decimal. Great. So 6 works. Sorry, 4 works. 4 works. By the way, okay, everyone, just let me put your mind at ease here. You might think now that, are you going to ever give us a list that's so long and we have to go? No, seriously. I mean, a long list just tests you how quick you are through it. I just want to know the basics. So maybe more than 7 factors, no more. Okay, so 4 works. Do you think that 5 works? Actually, it doesn't. No. Go ahead. Try it. Divide 24 by 5. Which means what? It gives you a decimal, not the whole number. Okay. Does anyone know? No. Okay. So now, what's the trick to knowing that a number definitely divides 5? One trick only. The number either has to end in what? 0 or a? That's it. Think about it. Okay, does 5 divide 5? Of course. What's the next number that divides 5? 10. 10 ends in what? 10 ends in 0. What's the next number that divides 5? 15, 20, 25, 30. Do you see what I'm doing? I'm only getting numbers that either end in what? 0 or 5. Does 24 end in either 0 or 5? It's not going to ever divide 5. Do you see? It doesn't make sense. Great. So 5 doesn't work. Do you think 6 works? Yeah, you know why? Because when we divided 24 by 4, we got how much? 24 divided by 4 is how much? No. 24 divided by 4. Go ahead. Is what? Which means 24 divided by 6 is 4. It's amazing. When you divide and you get one number, you can divide by that other number and get you always get the pair. So because the 4 gave me a 6, the 6 will give me a 4. Do you think 7 works? Nah, it doesn't. Yeah, 24 divided by 7 is 3 point something. Whoop. Once we see a point, we stop the process. Do you think 8 works? Yeah, because 24 divided by 3 gave us 8. So that means it's 8 times 3. Do you think 9 works? Nope. 10. If it's not going to work with 5, how is it going to work with 10? 11. 12. Yes, because why? Because 24 divided by 2 is 12, which means 24 divided by 12 is 2. It works out. Can anyone guess the last number? Nope. 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 Keep going. No, the number itself. Think about it. 24 divides 24, right? Every number divides itself. $24 divided by 24 people, $1 per person. Okay, everyone. No, wait. Let me teach you another trick. Everyone, pencils down, eyes on the list. What's this number? No, this one. No, the number, not the digit. You're right. If I said digit, it would be 2. So what's the number? How much is 12 out of 24? It's no. How much is 12 out of 24? It's half of it, right? Always know this. When you reach the number halfway through, the next number is the number itself. 12 is half of 24, right? The next number has to be 24. Once you get to the number, that's half the original number, the final number on the list is 24. Nothing else, in other words, nothing else is going to work between 12 and 24. 13 doesn't work. 14 doesn't work. 15, 16, 17, 18, 19, 20, 21, 22, 3, 24. Always like that. Never fail. Never fail. So you save yourself trying by saying, I just got halfway. Oh, I'm done. The last number is the number itself. Good. All right. Now let's look at what? Let's look at which number? The 16. Again, what number do you start the list with all the time? 1. All numbers must have 1 as a first divider. 1. Do you think 2 works? Do you think 16 divides 2? Of course, because 16 is what kind of a number? Even number. It ends with a 6. Remember, what are even numbers? These are the numbers ending in 0 or 2 or 4 or 6 or 8. Well, 16 checks out because it ends in 6. So 2 works. All right. 2 works. Do you think 3 works? Okay. Hey, let's do the trick. What's 1 plus 6? 1 plus 6. Does 7 divide 3? So 16 will never divide 3. See, the trick never stops working. Okay? But at least now you know that trick. Okay. How about 4? Of course it does. Because 16 divided by 4 is another 4. It just happens to be that way. 4. Do you think 5 works? Do you need a pencil? You do? All right. Oh, get this one. Okay. Do you think 5 works? Nuh-uh. Why? What did we say about numbers that divide 5? They have to end in what? Either no, they have to end in 0 or, well, guess what? 16 does not end in 0, and it does not either end in 5 too. All right. Do you think 6 works? Yeah, no, it doesn't. Try 16 divided by 6. You will get you'll get 2 points. Okay. So 6 doesn't work. 7 works? No. 8? Yeah. Hold on. 8 is how much of 16? Half. We're done. 8 will be here, 16 will follow through. See, once you cross the half point, the last number is the number itself. All right. Oops, sorry. 8 and 16. You can skip 9, 10, 11, 12, 13, 14, 15, because you know now they will never have a chance of working. Okay. Can you now tell me, just by looking at this list, sorry, at those 2 lists, what numbers do they share? What numbers appear on? Oh, you're missing one. 1. So they both share. Okay. They both share what? Ones, twos, fours, eights. Go ahead, copy them here. So I'm going to put them in green because those are the common numbers. Okay, everyone? We're almost done. We are 90% done with the process. Of the green numbers, which one is the biggest? 8. So let's divide both numbers, 24 and 16, by the biggest of the common choices, which is 8. All right, which is 8. All right, let's do so. 24 divided by 8. Anyone? I know it, but say again. 3. By the way, do you know why it's 3? Because 3 times 8 is 24. That's how you always check. And then 16 divided by 8 is what? Ladies and gentlemen, eyes on me. 24 over 16 is the same as what? 3 over, that's it. This is how we find how smaller the number could get. By the way, could it get any smaller than this? Impossible. You know why? Because we've already used the what? We've already used the biggest divider. So we've already have gone what? To the end of the whole process. Okay? So 3 over 2. So 24 over 16 is 3 over 2. How do you check? What's the title of this page? Simplifying fractions and checking with what? With decimals. Okay. What's the decimal for 24 over 16? Well, here it is. 24 divided by 16 is 1.5. So if you divide $24 by 16 people, you have got to give each person $1.50. And you get nothing in return. How about 3 over 2? It's also what? 1.5. And that's the proof that the original fraction and the last fraction are the same. Oops, sorry. You see how much we learned today? You learned tricks and you learned really the actual essence and philosophy of what it means to actually what? Decrease what do you call it? Reduce or simplify or decrease fractions. Yes. I guarantee you now you know more about the process than some grade 11 and 12 students, because all they do is just basically what? Plug it in. And here's the thing. You might say, why do I need to learn this? I could just plug it into my calculator. Yeah, fine. But what if you plugged it in the wrong way? Or what if you screwed up or something? Then you wouldn't even understand that your number makes no sense. Well, now you know. Okay, everyone, flip the page and let's do some exercises. All right. And let me show you the easiest way to, obviously, listen up, everyone. I don't want you to write all this just to reduce fraction. I'll show you how to do it really quickly on the fraction question itself. All right. So let's look at the first one. 4 and 8. Let's look at the 4. What's the first number that it divides? Always. What's the first number on the list? No. I'm talking about, okay. I'm just looking at the top part. You look at each level by itself. It's what? So I want you to write, everyone, look. I want you to write like an arrow, point to it and say 1. Do you think 2 works? Ask yourself one question before you answer. Is 4 an even or an odd number? Even. All even numbers are good with 2. Guess what? 2 is half of 4. We are done. The last number on the list is just what? The 4 itself. You got it. Okay. 8. What's the first number on the list? Do you think 2 works? Is 8 an even number? It sure is. 2 is admissible. It's possible. Do you think 3 works? No. 8 does not divide 3. 3, 6, 9. Sorry, 8 is not on the list. 4 does. And 4 is half of 8. So what's the next one? 8. What's the biggest number that belongs to both lists? How many people see it? What are the common numbers? 2 and 4. I always go to the biggest because when you go to the biggest, you guarantee that your final answer is your actual final answer and there's no need to change it anymore. So what I want you to do is either circle or highlight the 4. I will highlight. Oh, that's a bad. Now let's go with maybe yellow. Yes, yellow and yellow. So what do I do now? I know that basically what I need to do is divide 4 by 4 and 8 by 4. So I'm just going to write, so yeah, I'm just going to write it again. Everyone look. Divide by 4, divide by 4. What's 4 divided by 4? What's any number dividing its own self? No, no. What's $4 divided by 4 people? How much does each person get? There you go. Remember, any number dividing itself is just 1. Always think of the money example. $4 divided by 4 people, $1 per person. So 1. What's 8 divided by 4? No, 2. Remember, you have calculators. There's no need to guess. But hopefully, you know it. You'll exercise your multiplication table as you're in this course. Done. That's it. Easy process. You just have to take it slow. All right. Let's do the next one. 14 and 50. What's the first number on the list? Always, always 1. I want you to be organized. 1. Do you think 14 is an even number? It is. So what does it accept? It accepts a division by 2. So 2 is on the list. Do you think 3 works? Why? Use the trick. But also what? Use the trick. 1 plus 4 is what? 5 does not divide 3. The trick is, by the way, everyone, the trick does not just work for big numbers. It works as small as the number could get. Okay? In case you want to check. So 3 doesn't work. Do you think 4 works? Do you think 4? Do you think 14 could divide 4? You again, if you're not sure, actually do the division. Yeah, it doesn't. Look, everyone, 14 divide. There you go. Sorry, there's the decimal. Done. Add the question. Do you think 5 works? Of course not. It doesn't end with a 5 or a 0. Do you think 6 works? Gives you an infinite decimal. Do you think 7 works? And what's so special about 7? It's half of 14. So we're almost done the list. Or we're actually done the list. So 7. There you go. All right. Let's go with 50. 50 is a good number because it does end in 0. And we know some stuff about it. So there's 1. Do you think 2 works? Can you divide $50 by 2 people? Wait, wait. Does it end in a 0? By the way, all numbers ending in 0, 10, 20, 30, 40, 50 are even numbers. 2 works. Do you think 3 works? 5 plus 0 is 5. 5 does not divide, what do you call it, 3. Do you think 4 works? Nope. That gives you 12 and a half. Sorry. Does 5 work? Yep. 5 it is. How about 6? Nope. By the way, just so you know, listen up, everyone. If the 3 doesn't work, none of its multiples will work. So 6 won't work, 9 won't work, 12 won't work, 15 won't work. So, okay, 5 doesn't work. So 5 works, sorry. 6 doesn't. 7 doesn't. 8 doesn't. 9 doesn't. 10. It ends in a 0. All number ending in 0, divide 10. Or 100 and so on. 10. Okay, we're getting there. Do you think 12 works? Sorry, 11. Nope. 12. No. 13, 14, 15, 16, 17, 18. No, it doesn't. 50 divided by 20 is like 5 divided by 2. It's 2.5. but 25 works. What's 50 divided by 25? Exactly. It's 2, and it's half of the list. So what's my last number? 50. Yes, exactly. Yep. Yeah. You don't need to try 26, 27, 28, 29, all the way up to 49. You know nothing is going to work until the 50 itself. Good. You're getting it. It's amazing. You see, when you tell things like a story, everyone gets it. What's the biggest number common to both lists? 2. 7 doesn't exist here, and 14 is also non-existent. So 2 is my thing. There we go. So I just rewrite the fraction again, and I go divide by 2, divide by 2. 14 divided by 2 is, and guess what? It will never go lower than these two numbers. Done. That's it. Okay, let me do just 2 more, and then we're done for the day. The rest obviously is your suggested homework. Let me see. How many do we still have? We have this row, this row, this row, this row. There's 10 left. Okay, let me do a couple of the big ones with you. So let me do this one. And sure, let me do this one. All right. Let's put the list. First number. Do you think 81 divides 2? Again, any number ending in what? Everyone, eyes on me. Any number ending in 1, 3, 5, 7, 9. That's an odd number. 2 is only for even. Sorry, 2 is not a good candidate. Do you think 3 works? Without trying. What's the trick? What's that trick that we did on the board? What did we do with the digits? We added them. What's 8 plus 1? 9. 9 divides 3. 81 divides 3. Done. That's it. So 3 works. Do you think 4 works? Nope. Guess what? Everyone, let me give you another trick. You learned so much today about tricks. Odd numbers never divide even numbers. Done. Odd number, 81, will never be divisible by. Look, it will never divide 2 or 4 or 6 or 8. You can't. You can't give an even number of people an odd amount of money. You will still retain some to yourself. All right, so 4 doesn't work. Do you think 5 works? No, it doesn't end with a 5 or a 0. 6 doesn't, 7 doesn't, 8 doesn't, 9 does. I don't know if you know this. 81 is one of those what we call square numbers because it's 9 times 9. So it's one of those numbers which is a 9 times itself or a number times itself. So 9 works. Okay, we're jumping quite ahead. 10 doesn't work. 11, 12, 13, 14, 15, 16, 17, blah, blah, blah. You know what? I'm going to make it easy for myself and put what here? Yeah, I know the list is going to end with the number itself. Okay. What else works? Hey, if you try, you're going to find out that what? 27 does work. Okay. Here's the thing. That's it. That's it for the list. You can try any number from 27 all the way to 81. Guess what? None of them is going to work. So at least we know that my list is short. See, that's interesting. Is this a small number or kind of a big number? Kind of big number. Yet, how big is the list? Is it too big? No. 24 had a longer list. 24 had a longer list. So the size of the number is not a guarantee that the list is what is big. 126. Again, it is a big number, but there's no guarantee that it's going to have a big list. All right, let's try it. 1. 2 works. Whoa, slide step by step. 2 works because it's an even number. Does 3 work? Yeah, the trick says so. 1 plus 2 is 3. 3 plus 6 is 9. It checks out. So 3 works. Do you think 4 works? Nope. If you try it, you will get a decimal. 5? No way. It ends with a 6, not a 5 or a 0. 7? Again, sometimes you can't know. There are no tricks, so you have to kind of like brute force it and try 126 divided by 7. It sure does. It's 18. So 7 works. And by the way, if 7 works, also what works? Also what works? 18. If one of the pairs work, the other part of the pair does work. So you might want to say, let's put it here, provided that we don't know if there's a number in between is going to work. 8. 8. I don't know. Does 8 work? Nope, it does not. 9. Oh, sorry. It does work. 126 divided by 9. It sure does. And what does it give us back? 14. So that means 9 and 14 work. You see how beautiful it is? You can always just start putting the numbers in as they come up. 10 doesn't work. 12. I don't know about 12. Let me see if 12 should be also shoved in between those two. 126 divided by 12. It doesn't. 13. Find it really. No. 13 is not gonna work. Nah, it doesn't. So 1, 2, 3, 7, 9, 14, 18. All right. What's my last number, by the way? 126, number itself. All right. Hey, what's half of 126? Because I know the half number is going to work. Yep. 126 divided by 2 is 63. You see how you can do the list going forward or going what? Either you can go forward or backward. Again, as long as you populate the list, you're fine. 63 it is. Okay. 126 to 3. Sure. Yes. Good. Good. 21. Let me tell you actually 2 times 36. Oh, there's another number that works here. 126. By the way, you can generate the other numbers by dividing 126 by those and see which ones are missing. Sorry. 42 works. See, my list now is getting messed up, but at least all the numbers are there. Hey, let's divide 126 by what? So I'm gonna I divide by 3. Let me divide it by 7. We got the 18. Let's divide it by 9. We got it. We're done. That's it. No other numbers work. Okay, what's the number? The biggest number common between this list and this list? It seems to be 81 is not here. 27 is not. 9 is. Good. So I'm going to highlight the 9. All right, let's do this. So 81 over 126 divide by 9 divide by 9. 81 divided by 9 is 9. 9 over what? 14. And guess what? 9 and 14 will never get any lower. Sorry. For the noise I made. It has, yeah, it feels pain. The Canadian way, you always apologize.
Yeah, right.
I was once, this is true story. When was it, 2015? I went to New York with New Year's Eve with my sister, and we were just walking through New York, and it's New Year's Eve or the day before. It is crowded. This was 2015, but 2015 before COVID, and we're bumping into people because it's crowded, and we're just going, sorry, sorry, sorry. I swear, someone stops and he's like, "You guys are not around here, are you?" Like, no, we're from Canada. He's like, "Yep, that's why you're apologizing." I'm like, "Whoa!" In New York, just people bump into each other, and it's just a fact of life. You just bump.
Oh,
You're just sorry, 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 sorry. No, I got. But you know what?
yeah, me too.
You know what? They live there. They're numb to it.
Oh
I
my
guess.
god,
Yeah.
it
For
is.
us, it was different. Look at us. We live in London, freaking like ghost town. Like there's no one here. Even Toronto is not that bad sometimes. And it was New Year's. Like it's a tourist destination on that day. You know what? It was a bucket list of mine and hers. And I was like, you know what? We always see it on TV. Let's just go and see it. And it's 2020 was before COVID hit. Okay, yeah. It's the hype is real. It deserves the like the image that everyone portrays. Okay, last one, and then we're done for the day. 35. Let's do the list. One. Do you think two works? Okay. Again, is 35 an even or an odd number? 35. Odd. No even number will work. Good. That's so much load off our mind. So 2 doesn't work. Do you think 3 works? Do the trick. Yes, it doesn't work. You're right. Because 3 plus 5 is 8. Sorry, 8 does not divide 3. Okay. 4 is an even number. We said even numbers will never work. Everyone, just I want to show you something. Hold on. Pencils down, everyone. It's weird. Listen up. Odd numbers will never divide even. 77. 77 is a what? No, 77. Odd. It will never accept any even numbers under it. No way. Like to divide it. 2, 4, 6, 8, 10, 12. Doesn't. Here's the weird thing. Even numbers do accept what? I'll prove it to you. 18. 18. Is it even or odd? 18. Odd. No. 18. 1, 8. Remember, anything ending in 0 or 2 or 4 or 6 or 8 is what? Is even. So this is an even number. Guess what it divides? It divides what? It's an odd number. But you might say, but 1 is a special case. All of them do it. Great, no problem. What else does it divide? 2, because even divide even, usually. Guess what it also divides? 3, but 3 is a what? Odd number. So even numbers are good people. They do accept odd numbers. And not, it divides also what? 6, but that's even, so that's kind of expected. It also divides what? Which is what? Which is odd. So it's weird. Odd numbers, like 77, will never accept to be divided by any even number. Never. It never works. But even numbers do accept some odd divisor. I'll give you another example. Um, give me a big even number. Between 10 and 100. Let's not go so crazy. Sure. 52. Oh, I got the perfect one for 52. 1, 2, 3 doesn't work because the 5 plus 2 is 7. 4, yes. You know why? By the way, do you know why 52 is a very special number? How many people here play cards? How many cards in a deck?
52.
52. How many suits? 4 suits, right? 4 suits. How many cards per suit? 13, right? Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 3 face cards. See, 52 is a very common number for math teachers because we always use it when we play chance or probability and cards. Yeah. And also, by the way, also 52 is also an important number in time. You know why? There are 52 weeks in a year. Yep.
Right.
Yeah. You know why? By the way, just so you know, everyone, it's not exactly 52 weeks. It's 1 day short. 52 weeks. Everyone, look. 52 weeks times how many days per week? Go ahead. I want someone to multiply this. I know the answer. Go ahead. 52 weeks. Each week offers you 7 days. 360 what? But a year is either what? 365, or if it's a leap year, 360 what? So, but at least you're what? Most of the time, you're how many days short? Just 1. So that's why you all say a year is how many weeks? 52 if we forget about that extra day. Do you see what I mean? So that's why 52, when you say it, I'm like, whoa, she really gave me an easy choice. But my point is 52, which is a what? Is okay to be divided by 13, which is a what? it will never be the other way around. That's my point. Yes, that's the whole idea. That's the whole idea. I'm trying to teach you tricks to what speed up your process, and you don't have to worry about every single number. Okay. Do you think 5 works? Of course, it's 35 for God's sake. 6, nope. 7, nope. 8, 9, 10, 11. Oh, sorry. 7. What am I saying? 7 works. Look, 35 divided by 5 will give you back 7. So 7 is a part on the list. Guess what? Nothing else will work until what? We're done. See? No. Nope. Nope. Try it. 35 divided by 9. Almost. Not quite. 36 works for 9, but not 35. All right. 60. Everyone? 60. 1. Do you think 2 works? Is 60 an even number? What do you think? 60. Yeah, it ends in a 0. Do you think 3 works? Come on. 60 is like 6, right? If 6 divides 3, 60 also divides 3. All right. Do you think 4 works? Actually does. It gives you 15. So the 4 works. Which means, everyone, look, everyone, I'm going to start doing this now. Since I know that 4 times 15 is 60, look, I'm going to put 4, and I'm also here going to put what? Because I know it's going to happen to be on the list at some point. Do you think 5 is going to work? No, no. Does 5 divide 60? It does, because it ends in a 0. And guess what? I can try to see the other pair of 5. 60 divided by 5 is how much? 12. So 12 has to be somewhere here. See, now it's amazing. You know a way to populate the list from the beginning and the end at the same time. Do you think 6 is going to work? Of course. 6. Let me just move this here. 6 is going to work. Can someone tell me what's the other pair with 6? 60 divided by 6 is how much? 10. So 10 is going to work. 12, 15. Let's divide 60 by 2. Actually, let's divide 60 by 3. What do you get? 20. What? Divide 60 by 2. You get what? What's so special about 30 compared to 60? Halfway through, Jalil got it. So I am done. What's the biggest number in both lists? No, no, in both lists. That happens to be in both. 5. Because 35 is not even here. 7 is not even here. Is 5 in both? And it's the biggest. So you highlight. And we're done. 35 over 60. Divide by 5. Divide by 5. And it will never be smaller than that.